Hello and welcome back to our first science lesson of this term. And this term we're going to be focusing on sound. Now this would be something that we would normally do in year 4, but we're going to go back over it because it's something that we missed out when we were in lockdown last time. And we feel that you should know this. It also recaps some stuff that we have done in year 2. So it's kind of going back over knowledge that we already have. So sound. What is it? How is it made? And how do we hear it? And can we stop it? Can we change it? And can we measure it? So these are all questions that we want to be able to answer by the end of the unit. And a lot of these are quite in depth and quite important. And if you think about what sound is and how we hear it, it's quite an in-depth question. So let's have a look. So can I explain how sounds are made and how we hear them is what we're going to try and think about today. So try this. Place your hand on your throat like this and just against your windpipe here. And then make a humming noise and feel what happens. Can you feel your throat vibrating? You push down here just against where your windpipe is, just there. You should be able to feel the vibration that's going through there. And in fact, everything that makes a sound is vibrating. That's how sounds form. They're formed through the vibration. And you can see this in so many different ways. And a lot of instruments, you can actually see the vibration giving off the sound. So sometimes that's a big vibration, and that vibration can even be felt and sometimes even seen. We're thinking about a guitar string. If you pluck it, you can see the whole thing moving, vibrating. It's visible, but also we can hear it. And we're hearing it not by seeing the movement, but by feeling the vibrations. And it's the vibrations which are important to how sound is transferred. So another example is looking at a ruler on the edge of a table and you ping it. That ping makes a sound. That sound is a vibration. Sometimes it's so tiny that we can't feel it, but it's still there because you can hear it. So some vibrations are so minute in their movement, but actually we can still hear them. So those vibrations are still there, they're just not visible. So how does sound reach our ears? How does it get from whatever is vibrating to our ears? Well, it has to travel through something. We call that a medium. Sound has to travel through something. And no matter where it is, it travels through a medium in order to get to you. It's how the vibration is transferred. Usually this medium's air. So you think about how you're listening to me now necessarily is the speakers on your TV or your iPad or your phone, computer are vibrating. That vibration is causing the air to vibrate, which travels to your ear and you hear it. But you can also get sound that travels through solids and liquids. You can do this if you go underwater and you talk, or get somebody to talk the other end of a bath and you have your ear in one end. You can hear it. It sounds a bit garbled because of how the vibrations travel, but you can hear the vibration. If you think about solids, when you bang two solids together, you get a vibration. But if you put your ear on the table and tap one end of the other table, you'll hear it much different, much louder normally as well, because the vibration travels through the solid to your ear. So the object making the sound vibrates. The force of the vibration makes other particles in the medium, so whatever it's traveling through, vibrate as well. So me talking now is causing air particles to vibrate. By them vibrating, they're causing the next particle to vibrate, and so on until it is felt either by an ear or a microphone in the case of a computer picking up sound. The vibration forms what's called a sound wave. This is a compression wave, and that travels in all directions from the sound itself. Now, obviously, you can direct sound by stopping the vibrations that are traveling some directions. If you think about a loudspeaker, you've got a cone, and the vibrations are felt in one direction. And that's the idea of this cone. It is trying to channel those vibrations in one way. So you can, but if you were just to make a sound, that sound travels in all directions from that initial vibration outwards. And that's why you can hear it no matter where you are. If the sound wave is strong enough, it'll reach our ears and we can hear it. If we do it quietly, the vibration is very, very small and therefore doesn't have enough strength to reach wherever it might be. But the harder or the bigger the vibration, the further that sound can travel. So a nice way to imagine sound is by dropping a pebble into a small pond, and you can see the waves spread out from the center, getting gradually weaker the further they go from the center. Now these are vertical waves. You can see them moving up and down. Sound normally travels in what's called a compression wave, which one hits the next one, hits the next one, hits the next one. A really nice way to show this is with a slinky. If you get two people to hold a slinky on one end, and one person, rather than waving it up and down to see the wave travel along it, if you push it in and out, you'll see that wave travel along and back and along and back. That's compression wave. So, for example, hitting the drum will cause the skin to vibrate. So the air particles around the drum vibrate. And as they vibrate out, they travel further and further away. And the vibrating air spreads away from the drum. The further away from the drum it reaches, the weaker the wave, just by essence of energy conservation. It needs to use some energy in order to vibrate. The rest of that energy is transferred onto the next one and the next one and the next one. So finally, your ear will pick up that sound wave and your brain translates that vibration into the sound. And that's the interesting bit. It's how a vibration is transferred to what we actually hear, which is also why people can hear things slightly differently, but we might not know because we've always assumed that to be the same. So sound wave has reached your ear. How does your ear make sense of it? Well, this is your ear. So this is a diagram of an ear, a human ear, and we'll take a look at the different parts within the ear itself and what they do and how that helps us hear. So the first part is the pinna, which is the outer ear, this bit here. This part of the ear that we can actually see. It's shaped in a way that collects sound waves and steers them towards the center. So, we were talking about a microphone blocking out sound waves in one direction, or at least trying to channel them in one direction. Your ears try and do the same. It tries to collect any vibrations and channel that vibration down into the actual inner ear itself, where that vibration is translated. What you then have is what's called the auditory canal, or the ear canal, which is the other bit you can see kind of inside. If you look further down, you can see that inner ear, and sometimes you get wax in there as well. And sound waves travel along this tube, as they normally would, by vibrating down it. Now, the pinna and auditory canal are called the outer ear. They're the bits that have contact to the vibrations that we feel in the air, or whatever we're listening to. The next part is the eardrum, and you can see that little white disc down here. Now, this is a thin piece of tissue stretched like a drum skin. So if you imagine that drum skin, you can tell it's vibrating, you can touch it, and you feel it vibrate. What happens is the sound waves travels along the auditory canal and causes that drum to vibrate. As that drum vibrates, it travels into the middle ear, which contains the smallest bones in the body, which are called the hammer, anvil, stirrup. This is the hammer, which is the first part. The anvil is between the hammer and stirrup, and the stirrup is this bit here. If you know anything about horses, look at the shape and you know it looks like a stirrup, and therefore why it is called a stirrup. So when the eardrum vibrates, it causes these bones to knock into each other. The hammer vibrates first as the eardrum vibrates, which knocks into the anvil, causing the stirrup to move as well. These bones are also referred to as the malleus, incus, and stapes. So the next bit is the semicircular canals. This is part of the inner ear, but has little to do with actual hearing itself. There's a fluid inside the semicircular canals that moves around, and this helps us know which way up we are. It is to do with our balance, which is sometimes when you get an ear infection, why it affects your balance and how you control yourself. So it affects our balance. It lets us know what we're doing or the motion that we're feeling. It is a confusion between the motion we're feeling and what we're seeing, which causes us to feel what's called motion sickness. If we feel like we shouldn't be moving but look like we are, or vice versa, then we get this disparity, and that can cause us to feel motion sickness. The next part of the inner ear is called the cochlea. It looks a bit like a snail shell, and the cochlea contains around 15,000 tiny hairs. These hairs move when they are hit by sound waves and send messages along the auditory nerve. And this is the auditory nerve. Information from the cochlea, the hairs, tiny, tiny hairs vibrating, send impulses along the auditory nerve to the brain. And the brain then translates those messages into sound, those vibrations into sound. It's highly complicated, obviously, but actually the bits that are used aren't that complicated. The most complicated part being what the brain does with the information it receives. And our brains are incredible. From a sound entering our ear, it takes just 0.05 seconds for our brain to register and make sense of it. That's incredibly quickly if you think about all of the processes that sound has to go through in order to get there. And our brain works that quickly. Pretty incredible if you ask me. So your task, I want you to draw a diagram of the ear. You can use this one as an example. And then I want you to label the parts we've mentioned in this lesson. Hint, there's 9 of them. If you can label them and write a small description of each, that would be brilliant. I want you to think about the science skills you're doing here. Think about making your image nice and clear on white paper, perfectly straight lines with a ruler, and your label and information coming off of those lines. Make it look neat. Make it look like something we'd expect to see in our science books. I'm really looking forward to seeing this. And actually some interesting stuff come out of sound. Think about the difference between thunder and lightning. Maybe we'll discover why that happens. Goodbye. I'll see you in the next lesson.